Hey all, today let us solve this problem car fleet. Let's break down the problem and see how we can approach it. Let me check when is the last time I was solved this. Oh, it was 2025, so it's a long gap. Let's revisit again. Let me start the timer. Let's go. The current cars at given miles away from starting mile 0, traveling to speed target. Okay. We're given 2rs positional speed. Fine. Car cannot pass another car, but it can catch up and then travel it to speed of slowed car. A car fleet is a single car or group of cars driving next to each other, and speed of car fleet is minimum of any car in that fleet. Acha, makes sense. If a car catches two car at mile target, it will be considered as part of car fleet. What they're expecting, number of car fleets that will arrive at the destination. Let me check the constants. 10 power 5, 10 power 5, target. Okay. So, basically, let me explain the problem first. So, we are having n cars, and ith car is at position of I, and speed of ith car is speed of I. And now, suppose car is at 1, 2, 3, so on, nth position. Speed of car is speed of 5. All the cars start from their position. Now when they are starting from their position, they'll be moving towards the right side. So 0th car is moving towards, oh, it is target, not n, sorry. Target is 12. So is target greater than n? Yeah. Position of target is greater than position of I. Acha. So let's forget about n. We are having a target, and target is always greater than position of I. That means uh, suppose uh, let's take it as k is the maximum position of any car, and target is always greater than k. So 0 car will always 0 1 2 3, all the cars will try to move towards the target, which is towards the right of all cars, so somewhere else here. So now every car has its own speed. Now when does the current car meets the another car towards the right? When the current car speed is greater than speed of any car towards the right, it will collide with that car. Now when two cars collide to each other, collide in the sense not form a group like a fleet. When multiple cars come together, they will form a fleet. Now when they form a fleet, suppose 0th car has speed 10 and 1th car has speed 5. They both meet at point X, suppose. From point X, both the cars will move at a speed of minimum of all the speeds. So here what does minimum of all the speeds means? Minimum of 10 comma 5 comma so on. What are the speeds of all the cars which met at the position X? Got it? So in this way, like how many fleets will reach the target? So in simple terms, suppose if a car has speed x, with which cars does it form a fleet? The possibilities are all the cars with speed less than x. No, we can't take speed less than x. We need to consider the time to reach the target. Suppose time of zeroth target to reach is zeroth car to reach is target by speed of zeroth. Similarly, time of 1 is target by speed of 1. Now, how do you know that time 0th car forms a fleet with 1th car? When time of 1 is greater than or equals to time of 0. Time of first car is greater than or equals to time of 0th car. Then they form a fleet. Got it? Now, if you take uh, xth car, the cars which are having more time to reach the target than xth car will be forming a fleet. So in this way, you need to check how many fleets are possible from the given positions. Got it? So now, no, sorry, I'm addicted to Python. Yeah, let me take first. Let me figure out an approach. Zeroth car is position 10. First, we need a sorted version of positions and speed because we need to go in a structured way from 0 to maximum position. We can't go from 10th position and later check the 0th car. We need to sort position relative to speeds. Now, if you look at example 1, this is how it looks. 0th car at speed 1, uh, second car at position 3 and speed 3, fifth car at third car at position 5 and speed 1, eighth car at position 4, 10th car and position speed 2, yeah, fourth car 10 position, yeah. Now, what is the time target? Target is 12. For the first car to reach the target, what is the time it takes? It is at position 0. It needs to reach 12. So 12 minus 0, distance by speed by 1. Okay. So it is 12 miles per hour. Is it miles per hour? Yeah, miles per hour. Now if you see the second car, it starts from position 3 and it needs to reach target 12, and it goes faster than first car. So there is no chance for the first car to make fleet with the second car. So 3 comma 3 we have. So time, basically I'll figure it out fast. Second car time 12 minus 3, 9 by 3, which is 3 hours. Sorry, I wrote it speed, I got confused. Yeah, time 3 is 12 minus 5, which is 7. 7 by 1, it takes 7 hours. T4 is 12 minus 8, 4 by 4, 1 hour. T5 12 minus 10, 2 by 2, 1 hour. So if you look at uh, this pattern, you can see that first car cannot make fleet with any other car. Now second car can make a fleet with third car, and fourth car can make a fleet with fifth car. So you can see there are three distinctions. Now if you look at the pattern, you see this 12 hours. 12 hours can never meet any car because it is the car which takes more time. Now 3 hours can meet with 7 hours because but we need to change the speed of that car at that position. uh, should we care about it? Let me think. Hmm. So yes, the reason we are taking this 2 at a block is once third car meets with the second car meets with the third car, even second car takes 7 hours time. So the moment fourth car meets with the fifth car, even fourth car takes 1 hour time. So this is not much issue. Let me figure out. So if you are taking current car X, you check if there are any cars to ride which is having more time. So let me frame it in opposite way. If you are having car at X, and if you think this must be minimum, you consider cars towards left which take more time, less time than this collide. Equal times does it collide? That's what I'm thinking. It might collide, but it might collide somewhere else later, right? Not here, that's fine. Let's not complicate this. Yeah, if you're taking exit car, you consider what are all the cars which are having less time than current car. So the leftmost car which is having which is faster than current car, we remove it first. The leftmost car which is faster than current car, we remove it first. Suppose there is some cars in between. 4, 5, 6. Now from 3 to 7, this all can form one fleet because all these cars move faster than 7-hour car. Yeah, this makes sense. Now how do we remove leftmost element from the array? We are having a data structure called stack. It follows LIFO principle. The last inserted element will uh, go out first. Now here you need to uh, think in terms. We are at, yeah, let me keep it simple. we are having a stack. So if we are at element text, if there is any element in stack and which is having less time than current element, we pop from the stack. We are at 12. 12 is not in the stack, we push 12. We are at 3. 3 is greater than 12, so we add 3. We are at 4. 3 is less than 4, we pop it, make it 4. 5. 4 is less than 5, we make it 5. 6 is 5 is less than 6, we make it 6. We make it 7. So after 7 it's 1, so we stop. Again we add 1, so 1 is less than or equals to 1, so we keep it 1. So in simpler terms, if we are having an xth vehicle which takes so and so hours, all the vehicles which are towards left which take hmm, yeah, which take less time than this, in the sense they move faster than this, we form a fleet. We take it as one fleet for here. In future if it meets, we'll also make fleet there. In this way we'll move forward. Got it? Yeah, let's go to the implementation. Before going, let's check the complexity. Since we are traversing entire position array once, complexity would be of n, where n is length of position. We also need to sort position, so it is n log n. Yeah, and we need to maintain a sorted array of positions. It is so often for the given constraints 10 power 6 plus 10 power 6 log 10 power 6, 16 into 10, 160, 10. Okay, it works. So let's go to the implementation. First n is length of positions. Yes, now position, not positions. We need a vector which needs to store sorted array of position and vector of pair of int comma int. Let's take it as, let's give it some naming like v, pair of int comma v. Okay, for int I equals to 0, I less than n, I plus plus, we dot push underscore back of what position of I comma speed of I. Yeah, we had paired vector. Now just sort. Why is my typing so bad? Yeah, we dot sort dot. Yeah, now we have a sorted array. Now we need a stack. My god, I'm making too much syntax issues. For int I equals to 0, I less than n, I plus plus. Now if stack dot empty, just push back and continue. Not result, stack dot push, stack dot push back off. What we need to push back? Time. Let's find time equals to target minus v of I of 0 is the time, sorry, position, by, let me take double, who knows if we have decimals, by v of I of 1, which is speed. Let me make it as double here too. Just push back time, continue. Oh god. Now what you need to check, if there is any vehicle which goes faster than current. So while not stack dot empty, god, my fingers are not working today. While not stack dot empty and stack dot back is less than or equals to time, we just stack dot pop underscore back, right? Yeah. Now we push back of current time. Let's go. This makes sense, right? We pop all the yeah. Now number of fleets reaching the target is yeah, I got confused, like speed of 5 might be 0. No, it's greater than 0. So we just need to return number of fleets in the stack size. Let's double check the code. Positions dot size parent v pushback of speed and position, sort it. We have a stack, we have time. If stack is empty, we just push back, else we'll pop all the elements which are faster than current. Now we push back of current element time and we return the stack dot size. Let's see whether it works. Oh, v dot parent, right? First, not second. By actually, I'm too bad in syntax today. Yeah, test cases works. Let me submit the solution. Output 1, expected 2. We start at 6, at speed 3. Time it takes. Time this takes to reach target. Target minus v of I dot first. 10 minus 2 by 2, 1. 4 by 3. 4 by 3 is 1 point something. It takes more time, right? Did they say to convert it to int or something? Wait. Ten minus 6 is 4. 4 by 3. 6 3s are 12. Oh man, let me check it as time, right? Vector int. I think they're only worrying about int. Let me confirm. vector int. Yeah. Hmm. 1 and 1. We take floor of how come? Oh, expected is 2, I got 1, so then it must be a double. Vector of double stack dot empty. Okay, stack dot back less than or equals to time, stack dot pop back. Why it is 1? Let me print the element which got popped. Wait, but let me print time first. Think. Oh, it is taking S1, that is the reason. Target is int, okay. Now let's see. Yeah, this is the reason. Target and pair contains int. Let me submit this. Yeah, double works. So as we said, complexity is of n plus n log n, which suits the given constraints. And since we are using an extra array to sort the elements, it is of n, and we are also using stack, which might take O of n. Yeah, this is the time and space complexity of this solution. Let's go.